So, as many of you in the audience and listening audience know, I'm quite interested in NLP. So today we're quite fortunate to have one of the leading researchers in NLP, Roy Schwartz. He is professor of natural language processing at the Hebrew University of Jerusalem. Welcome to the Data Exchange podcast, Roy.
Thank you. I'm really excited to be here.
All right. So one of the main reasons, not the only one, that I asked you on this podcast is because of this interesting survey paper that you co-wrote with several other people, entitled "Efficient Methods for NLP: A Survey," which is basically about getting the most out of limited resources through various means. So let's start with the motivation for this in general, because you're coming from it from the academic side, and maybe at the risk of stereotyping academics, maybe you folks have even more limited resources than industry people. So very briefly, what was the motivation behind the survey paper?
Yeah, so I think as you said, I come from academia. Where we don't have the extreme budgets that huge tech companies have to run experiments and kind of them. So this is one, and it totally motivated me towards this work. Another is to some extent the environmental aspect. I'm a person who cares a lot about the environment. I try to do my share. I bike to work. I try to turn off the light when I leave the room, all that stuff. And a few years back, I was working at the Allen Institute for AI in Seattle. And I was riding my bike and I get into my office, and there was a GPU machine in my office running experiments. And I don't know if you've ever seen one. It's a very big machine that's very noisy and very emitting a lot of heat. And kind of was thinking whether I'm doing my share, and then I'm running pressing enter and all the CO2 that I saved by doing what I do is gone to waste. So I started thinking about these problems, and me and a few other folks at AI2, Jesse Dodge, Noah Smith, and Oren Etzioni wrote a piece called Green AI, where we talked about this trend that models are becoming bigger and more expensive, and that we should also pay more attention to efficiency, and not only getting another epsilon on your favorite task, but also trying to cut down on the costs. And this paper got quite a bit of attention, and ever since we were involved in various initiatives trying to promote this topic within the NLP community. And the most recent one was a workshop that we organized in the place called Dachstuhl. That's a town in Germany, and that hosts this kind of mini conferences that we had like 25 brilliant and diverse researchers that care about efficiency in June, just a few months ago. And we just sat in a beautiful castle and talked about efficiency all day long. It was a really fun event. And one of the things that came up is that we currently don't have a resource that outlines the various approaches that people have for efficiency. And so we brought this up as one of the potential deliverables of that workshop, and many people were excited. We ended up with a group of about 20 researchers from, I think, about a dozen different institutes. That each of them kind of gave their own share. I won't list all the names. I just would like to mention a few people that led the effort, just to give the credit. We had 3 students, Marcos Treviso, Tianchu Ji, and Jiun Li, who were the students driving this effort, and 2 PIs, Leon Dergzinski and Niranjan Balasubramanian, who really pushed this forward. And so each person wrote their own a few, maybe a section or a subsection, and we got this up into a nice piece of work that we released last month. So that was mainly our motivation. I think the key things that we were thinking about, we were discussing while we were brainstorming the paper, one was who would be the target audience. You can think of various people who would be interested in that, and we, as academics or as people who do research, we thought about people who do research in NLP. to be the main audience, even though it's definitely has value for people who are not researchers, but just practitioners. So we thought about two main use cases. One is that you want to use the NLP technology, whether for particularly for research or even for industry, and you're limited by your resources. And what can you do? I mean, what are the available options for you to use fewer resources than maybe get better results for, using your limited budget? And the second is people who are interested in this topic and are new to the field and want to start doing research, want to promote and think of even more efficient methods for NLP. So we want to kind of outline the different options out there, and in particular talk about open and exciting problems that are still out there.
All right, so let's go quickly through the main taxonomy, main types of squeezing out efficiency. So the first one is data. So here, I guess the idea here is, can you get by with less training data, or better utilize the data you already have? So immediately people listening to this will say, well, isn't this counter to the main trend, which is the unreasonable effectiveness of data? As look at, for example, GPT-3, right? So and things like that. So it seems like these models get better the more data and the larger the model is. So under the heading of data, so what is the main takeaway as far as efficiency?
Yeah, I think you're making a very good point, and I think it goes beyond. I mean, data is just one example of it, but I mean, I think what we've seen with deep learning is that scaling works. Basically, I mean, I think this is one of the key properties of deep learning that makes it so successful. You make things bigger with more parameters, with more data, with more layers, with more whatever, and you typically get better results. And kind of this is where the field is going, and we're trying to think, okay, can we be smarter than just increasing everything? And can we make a better or more efficient use of the existing resources rather than only increasing them? And so to give you some intuition of why more is not necessarily better with respect to data, I can tell you about a paper that I published with some colleagues led by Swamdipta at AI2 a couple of years ago, which was titled Dataset Cartography. And there the idea was that we build what we called dataset maps, maps of datasets that where each point in the map was a different training instance. And we were able to break down datasets into different regions, such as we found this was not for pre-training, this was for downstream tasks.
So were you doing some kind of clustering or topic modeling? So how were you?
We were what we were doing is we were looking at how different instances behave during training. So if a model makes an accurate prediction with very high confidence throughout training, say you have k epochs, say 5 epochs, and every time the model gets this example right, then it's probably not that important. It's probably very easy for the model, and maybe it doesn't get that much value by seeing it. On the other hand, if you look at other examples that the model maybe sometimes gets right or sometimes gets wrong, or which we call ambiguous examples, these are the ones that potentially have much more value for the model. And what we saw is that in these experiments, we cut down the training data by taking only the top third most ambiguous examples, the one with the highest variance in confidence score. And we saw a very small reduction in your end results, so in your in-domain end results. So you're not losing that much, and you're getting 3x speed.
Quantify the reduction in accuracy, roughly.
Well, about 1 point accuracy across tasks, across I think several models and several tasks.
And then you're only using 1/3 of the data. That's insane.
But that's not the interesting part. The interesting part is that when we evaluated these models on auto distribution, on data sets that they were not seen during training, we actually got the models that perform better than using 100% of the data. So we cut down the data by 1/3, lost a bit in your in-domain, but earned maybe a 2 or 3% on outer domain. I think this is a very...
Give us a sense of, so was this... was this particular work, do you think, generalizable? So in other words, if I take these ideas, I can apply it to any kind of domain?
Well, I mean, this is a very good question. I mean, I think we've shown it for several tasks when you're taking a pre-trained model and fine-tuning it. This is the setup that we were using, and I think several people reproduced these results and got incorporated various extensions of them in the past 2 years, ever since our results were released. I think a very important question that relates to the survey that we're talking about is, can we come up with something around this for pre-training? So say you have a very large corpus as Common Crawl or the internet or whatever you use to pre-train your model. Can we find these good examples, these ambiguous examples, these high quality examples that using only them would result in strong performance and more generalizable performance? And this is still an open question.
So Roy, what if you had an idea of the eventual application? So in other words, you know that at the end, I'm going to apply this to a medical or healthcare domain. So I start out with this massive Common Crawl or whatever, and then can I kind of say, well, in the end, I'm actually just going to use this in finance or in sports or whatever, right? So can I actually reduce the training set up front?
That's a very good question. I mean, I think, you know, the most naive thing that you can do when you have this is take a model that's been trained on all your data and then maybe continue pre-training it. There's been a very influential word called "Don't Stop Pre-training," led by Sachinger Rangan a couple of years back, that said, okay, once you have your task of interest, take your pre-trained model and then just continue pre-training it on on data from this domain. The question is whether, I think what you're asking is whether you can skip the process of pre-training to begin with and just fine-tune and just pre-train on your data of interest. And I think there have been some, I can't think of one result that, of a particular result, but I have seen efforts along this line. It's definitely an interesting line of research. And I think, I mean, it's not entirely clear. I mean, it really depends on your motivation, because, I mean, if you have the model already trained, you can think, okay, why not use it for your medical or your finance? I mean, if this is the best way to get improved results.
Right.
And sometimes you have
you would
other
still
constraints.
if you have this large model, you may have to fine tune it anyway. So you might as well start with the large model. By the way, so a question about the result that you described earlier, the one where you ended up using only a third of the data. Did that mean the eventual model size was also much smaller?
No, actually, we didn't. We kept the model size fixed. The only thing we touched was the data. This is a very important point. I mean, so we did very controlled experiments, training the exact same model, and we did some hyperparameter tuning for each model separately. And our base case was the train on 100%. We had a baseline that took a random set of 33%, right? I mean, so what happens if you just take 1/3 of the data? This got much lower results, as you might expect, especially on out of distribution. And we had our case of doing a smart selection of this 1/3 of data, which got overall the best performance.
So it doesn't quite help you when it comes time for inference, but we'll get to inference in a second.
We will.
In a second here. Yeah. So next category is the design of the model, which is basically, I guess, more smarter architectures and things like this. So what is the high level takeaway for this class of efficiency methods?
Yeah, so this is, I think this is one of the interesting and diverse parts of our pipeline. I mean, we take for granted that the great majority of the community is working with transformers, and one thing that's truly remarkable is how how much the field has changed over the past 5 or 6 years and how much we're still using the same transformer architecture for 2016 or 2017, which is pretty remarkable if you think about it. And there have been a lot of efforts trying to take this and making it more efficient using various methods, whether it's trying to approximate the self-attention component, which is the main bottleneck computationally, trying to use the sparse variant of the model, trying to do parameter sharing. And I think maybe the most recent approaches that I'm aware of that I think maybe are the most promising are methods that try to do retrieval to augment these models with retrieval components.
Using kind of a information retrieval. Right.
Exactly. So, I mean, I think that the key question, I think, is a very important open question, is whether the knowledge that a large model has should be stored in its parameters. So basically, when you ask a model a question like who's the president of the United States, should this information be encoded within the model parameters, or should it be encoded in some external database and the model can access it, understand your question, quote unquote, and then access it to retrieve the information. And I think we've seen some promising results that the second approach is getting very good results with models that are order of magnitude smaller than, say, GPT-3, maybe taking a model that's not 200 billion parameters, but maybe just 1 billion parameters plus a large database and getting comparable results. So I think this is a very promising direction. I think it's not clear that the answer will be...
I like why you when you said just 1 billion parameters.
Yeah, I still remember the days where they wouldn't release GPT-2, which had 1.5 billion parameters because it was too dangerous, quote unquote. And
so this
where are we today?
This notion of combining a large model with a knowledge base or database of some kind is just researchy, or are you aware of some production commercial where they consciously made a choice? Okay, so this is good enough to use.
Well, I'm not a big expert on what's commercial products use. I mean, I know most of these companies are not happy to share exactly the architectures that they use. I know, for instance, DeepMind has been a strong player in trying to promote this approach. Google in general, I think. So, I mean, it's obvious that, I mean, when you're Google and you have the internet.
They might be dabbling with it already.
Yeah, I can only assume. This is not something that I have concrete information about.
In terms of the model design area, so this, in your mind, this is kind of the most interesting thing, this kind of hybrid.
I think all of them are important. I think a mixture of expert approach has been used quite a bit recently. That's another. I think this illustrates another a very important issue about efficiency. That there's often a trade-off. In mixture of experts, what you typically do is take one component of the model, and what's typically used is the feed-forward part, but you can think of other components, and use n copies of it, which effectively means that you're increasing the model parameter count by, say, 10x. But at the same time, every time you run the model, only one of these experts is being used. So the runtime doesn't change almost at all.
So what's the point?
The point is that the different experts have each their. I mean, this is just high-level intuition. I don't think anybody really understands what's going on there. But each expert, say, has their own expertise, or there's something that they can do a better job at fitting a given example than one single expert that has to handle all of them.
So the routing to, let's say you have 10 of these experts, the routing to expert one, is that by random, or is there an intelligence?
No, it's not random. It's a learned process that learns to assign a given example based on some embedding of that example to the correct quote unquote expert. And this is an example where you make the model much less efficient in terms of, because you need much more space. I mean, you can't store it on small devices, obviously, but you don't pay. You pay a much smaller price in terms of runtime or in terms of energy or whatever. You can also think of the reverse process where you do parameter sharing, What does parameter sharing mean? It means that you can say, instead of using different weights for each layer of your model, you can use the exact same layer, just duplicated several times, maybe many times, maybe more, not just 20 or 50, maybe 100 or 1,000 times. This would create a model that's much smaller in terms of memory footprint, because you're just using one layer of your parameters, but your runtime is much more expensive because each layer is run multiple times. So you end up with a potentially much slower model. So I mean, this is just two examples of the two sides, maybe of the coin, of how you can, on one hand, increase the parameter count but not pay any price into the runtime, or decrease it but increase your runtime. This is also something that you see quite a lot when you think about efficiency. There's also often trade-offs. There's hardly ever a perfect approach that wins on all fronts.
All right. So the next category is training. So right now the situation in NLP for those of us who are users and practitioners is we go to a model hub. There's 1,000 different embeddings to choose from. Somehow we pick one. It works well, but usually not well enough to deploy because it was trained on general data. So then we have the fine-tuning step, right?
Yeah.
So what is the situation in terms of research and pre-training and fine-tuning?
Yeah, so again, we made this conscious decision to separate the two because I think they involve very different methods. And
yeah, describe each one. So
yeah, I think that some of the stuff we've talked about so far also applies to either in many cases. So again, so thinking about pre-training again, so you can think about using less data, or thinking about retrieval models that we talked about earlier. You can think about changing the optimization objective. I think there's less things that are concrete to this part. So I'll talk more about fine-tuning. Fine-tuning, I think there's the field of NLP, at least in terms of research, has been moving towards fine-tuning using less and less data over the past couple of years. I think GPT-3 was
I think right now probably a few hundred examples, right?
Maybe even a few dozen examples, maybe even zero, what we call zero shot, with no examples whatsoever.
Depends on the domain. So in the medical domain where you can't make mistakes, you may need a few hundred, right? So,
exactly. I mean, so I think that this is you can think of this is one line of research that tries to say, okay, we don't need almost any data. I mean, this is very helpful actually in terms of in domains where you don't have much data. I mean, again, the trade-off, as you mentioned, with how much you care about the epsilon in your performance. Maybe you would use every data that you have, and maybe in some domains it's fine to just use fewer examples. Another very active area of research along these lines is using.
But Roy, but generally, so what you do is you have this big model, then you realize it's not good enough to deploy because it's trained on internet data. You want to fine-tune it for your domain. You have a few more labeled examples, and then there's kind of an iterative process usually, right? So.
Well, the process is not exactly how you describe. I mean, there are various pipelines.
So it's not. Sometimes it'll work right away. Maybe then you realize, oh, I need more data, and then you, right?
So I mean, when you pre-train, you're talking about the tasks in of the family of language models. So you have a sentence, and you maybe mask away some of the words, and you want to complete the missing words, or maybe general. Causal language model, we just want to predict the next word. This is the general objective.
I guess I was more talking about fine-tuning.
Yeah, the next step, now that you have a concrete task, say you want to do sentiment analysis or question answering or summarization, is that you take this pre-trained model that was trained with one objective, and now you want to apply it with a new objective, say again, question answering.
Or named entity recognition.
Yeah. Various other examples, and in this case, this is where labeled examples come in. So, as I said earlier, you might want to take your pre-trained model and continue training it on your in-domain data, say your medical data, your legal data, or whatever. this requires only unlabeled data. So maybe you can take doctor notes with no label whatsoever, but just this is medical text. So this is helpful for, adjusting the pre-trained model to your domain of interest. But once you've settled on this, now you want to take it and fine tune it on your task of interest, as you said, in name entity recognition, question answering, and so on. And here you can think of, again, several things. One, you can think of, okay, how can I use less data here using few shot or zero shot examples? Another thing you think of, which is a major bottleneck as well, is whether you need to fine tune all the weights of your model. So say you have a model, not even GPT-3, say T5, which is 11 billion parameters, and you have 5 different tasks that you want to fine tune it on. So now you need to save 55 billion parameters, not because each of them, you have to save all the parameters of that model. So there's a family of approaches, typically called the leading one called adapters, that try to fine-tune only a fraction of the parameters. So you basically save the basic copy, which is you still need it obviously, but instead of adding the same amount of weights for each new task, you only add a small number of weights. Typically, you can get to even 1% or even 0.5% with the best models that we have nowadays, and this allows you to save a substantial amount of space.
Usually the goal is maybe I don't know if this is your experience, Roy, but the goal usually is for the fine-tuning step, hopefully you can get by with CPUs even, right?
That's also, CPUs have been improving quite a bit recently, and I think some people are using it also to fine-tune, definitely.
So you don't need the massive supercomputer of GPUs at that point, right? Ideally,
it probably depends on how large your model is. Whether it can fit in memory, how much operations I need to do. But when using smaller models, yes.
This notion of fine tuning is related to an old concept around active learning, right?
Active learning is something that, at least in my head, is a bit different. Maybe you're talking about few-shot learning, where you, in few-shot learning, maybe relates more to active learning, where you say, I only have a few examples. In active learning, you say, okay, I have many unlabeled examples. I only have a budget to annotate several of them. Let's pick the one that are most useful. This is something that we've seen quite a bit in the recent few-shot literature. So definitely. Again, you can think of other approaches like space-efficient approaches. And I think that the major challenge, that if I have to pick one challenge of fine-tuning, is can we get the good few-shot results that we see with huge models on much smaller models? We're seeing GPT-3 doing wonderfully with only a handful of examples, but smaller models still need quite a bit of them. So can we find ways to do good few-shot learning with just with smaller models that can fit on smaller devices?
Yeah. And so, by the way, Roy, just generally everything we've talked about, because when people think of models like GPT-3, the word foundation model has been used, which I don't actually like that phrase, but anyway. So, but generally, on the other hand, when researchers evaluate these things, they evaluate them against very specific tasks and benchmarks, right? So it's not like it's a general, here's a model, we know it's good on everything. No, so each direction that we've talked about here, data, modeling, and so on, fine-tuning, when you say, okay, so when I reduce the amount of data that I need, the model is still great, but great only for this specific set of tasks, right? So.
Yeah, you're making a very good point. We have a section about evaluation. Maybe we'll get there towards the end if we have time. I think evaluation is a huge question. I think, when I was much younger, maybe 10 or 15 years ago, when I started doing NLP, nobody wanted to create data set. It was something,
this must have been before. This must have been before deep learning.
This was before deep learning, yes. And I think nowadays people are much more excited about trying to find ways to better evaluate our models, better try to really push them to the limit and show you what can they do and what can they not do. And you're definitely right. I mean, we every given scientific paper has only so much that they can, so much budget, so much time that they can spend on evaluation. And typically, people evaluate their approaches on maybe 2, 3, 5, maybe 10 different data sets. But obviously, that's I mean,
So
naturally, the more data set you have, the better the evidence that you get. But it's not perfect. No.
So with that said, I'll put you on the spot, right? So if I put you under pressure to build to generate some more efficiency out of a specific NLP model, what are the first two to three things you would try?
Are you asking which data sets I would use or which
No.
methods?
Just so generally, so without knowing this is an impossible question. So which first two or three things around efficiency would you try to do first if someone gives you this?
So I mean, I think maybe you're asking about inference, which we haven't talked about yet. So
No,
I mean,
not inference, just building the model. So which first two to three ideas? Impossible question for an academic who wants to be super precise. But generally, if you were like in industry, what two or three things would you try first?
So okay, I'll try to scope you a bit to just to give some answer that I can relate to. I mean, assuming I want to do some sort of pre-training, I think filtering the data in some way is something super important that helps you reduce the costs. I think it's very hard to get along without it. I would try to. I mean, I think again, I mean, this is maybe the data part that I would do. In terms of the model, I mean, I think as I mentioned, it's very hard to trust results that use a different model rather than the transformer, because transformers have been shown to be extremely robust, and I think we haven't found yet something to outperform them consistently. So maybe kind of thinking about augmenting the model with some sort of retrieval approach would be something. Again, this is not mature enough for technology at this point, but still something that I think is worth trying.
By the way, and on the retrieval approach, which interests me a lot, one of the challenges there is there's not really, easy to use open source tools and knowledge bases and things like this, right? So it's not like some of these other approaches. Maybe you might have more generally available tooling, right?
You're absolutely right. I mean, I think you can use an off-the-shelf search tool, say Google or Bing or whatever. But I mean, this is very hard when you think about it in a scientific perspective, because you don't know what's inside Google, you don't know what's inside Bing. I mean, they can change from today to tomorrow. I mean, I think you're asking. I mean, if I had to deploy something that works, and I think when I want to ask something, I ask Google, even though the answer I got today might be different than the answer I get tomorrow.
What about Roy, investing in tools so that fine tuning becomes much easier, so that you can even have the domain experts who may not necessarily know much about NLP but really know the data well, so that they can be empowered.
Definitely.
They can be empowered to do this fine tuning, right?
Yeah, totally. And so I think the few shot learning, I don't want to call it revolution, but I mean, it's a very strong trend in NLP nowadays. And one of the main, the leading approaches is something called prompting, where you take a model and you ask it some question and you use its original objective to filling words, whether it's masking words or filling the next word, to give you the answer. And you can use different prompts that are generally more interpretable than other methods. So you can take experts that don't know much about how the model works, don't know much about how fine-tuning works, but can play with the model and get potentially find the right prompt that would be most useful for the use case. And
to people who are familiar with this, I mean, some of these people are like basically like prompt geniuses, prompt engineers, and just because someone is a great developer and coder doesn't mean they're great prompters.
Yeah, I mean, it doesn't mean that they're great dataset creators also. I mean, I think NLP is becoming a very diverse field where different people with different, I mean, you can think of theory people that are trying to find the next algorithm that works perfectly well. You can think of good engineers that will make the good implementation that works super fast. You can think of dataset creators. You can think of prompt engineers. There's lots, this is part of what makes NLP such an exciting field. There's room for many people with different and diverse skills.
Yeah. All right. So very, very quickly, because I want to get to a little bit of what you're doing at Hebrew University on the inference side. What's happening there? I at a high level, I guess compression and distillation, right?
Yeah, totally. I mean, I think so inference is probably the most. I mean, arguably, if you think of, I don't know, CO2 emission, maybe there's some estimates that they're under controversy, definitely. But I mean, some people estimate that maybe 80 or 90% of all AI computation is done on inference, not on training. So
Right.
if you think of people like myself who are struggling with training models, the great majority of people are running the models.
Right.
I think, every time you search Google, for instance.
Right.
So there's maybe, I think this is probably the most well-studied research area within with respect to efficiency. And there have been multiple approaches. Probably, as you said, the distillation is one of the most studied approach, where you, in a few words, you have you first train your large model, then you train a smaller model to mimic its behavior. So it's trying to predict the same, make the exact same prediction as the larger model. And this has been shown very robustly to work much better than training the smaller model on just the downstream task. So this is one very popular approach. Another approach that, from what I understand, works very well in industry setup is quantization, where you use lower precision of your folding point. Instead of using 32 bits, you use maybe 16 or 8, or even some approaches even go even lower than that. And there you can also obviously save a lot of space, but also run these operations much faster. There's a bunch of other approaches. I'm particularly excited about.
So Roy, generally, for those of us who don't follow this closely, so like you said, right? So 80%, arguably 80% of energy costs are on the inference side, right? So what about if you were to guess, what percentage of researchers' time is spent on inference versus training?
Probably the other way around, maybe like 10 or 20% at most. We're not. I mean, we try to build the models. Other people try to use it. I mean,
So then that's my other question: is the inference, the stuff happening on researching better inference, more efficient inference, is that a completely separate community compared to the people doing research and training?
No, I wouldn't say so. I mean, I've done some work on efficient inference, and I think, I mean, lots of research about the distillation, about pruning.
But the reward system for professors and researchers skew towards training, right?
I mean, you can think of various examples. I mean, even people doing NLP for healthcare are not typically doctors, right? I mean, maybe they collaborate with doctors, but the computer scientists within us are probably not doing it because they need to have better tools for writing medical notes or doing, legal NLP, are not lawyers. I mean, so we often build technology that other people will use. That's part of what science is about.
Right. But within the NLP, within the ML community generally, right? So you probably get rewarded for beating benchmarks rather than squeezing efficiency out of inference, right?
Yes, I think that's what we're trying to promote with the green AI approach. That's saying, I mean, don't only reward people who get better efficiency, better accuracy results, also reward those that get more efficiency. And I think I'm not even sure that I agree with the original claim that you made that this is not relevant for researchers, because I can't work with GPT-3. I can't fine tune it on my task of interest because it's just too big. But if I took it and distilled it into a smaller model that I can work with, but is much better than a incomparable model trained from scratch, then this will be very valuable to me. So I think these methods that take the models and make them smaller, even after you have the original model that someone else trained, are still valuable to anybody doing research in NLP.
I think, but also, honestly, Roy, part of it is the way the media covers these things, right? So, when was the last headline you saw? Hey, DeepMind just released the most efficient.
I totally agree. I mean, I think we're all very. We're excited by breakthroughs, and breakthroughs typically come from things we couldn't do earlier and we can do today. We're much less excited about, okay, now people can actually, everyone can actually use it, not just, the one person who got there. I think I could imagine a headline like saying, okay, now we can take this huge device and get something of a similar quality that works on your phone. I mean, this is something that would obviously be mostly about efficiency, but would not necessarily be a better model than something that's out there. So I could imagine something like this.
So give us a sense, Roy. So by the way, so Green AI, which is one of your research areas, is also on my radar, because I'm starting to see people in industry, it's particularly in large companies, obviously, because it affects their bottom line, really talk about it. So on the academic side of things, so how much interest and awareness is there in this kind of green AI topics?
Yeah, you're asking a very good question. I mean, so I've been myself and my colleagues have been trying to work hard to promote this topic. I mean, so as I mentioned, the doctoral workshop that we organized, we also had we're part of a group appointed by the ACL, the Association for Computational Linguistics, which is the main scientific body of the NLP community, that appointed us to trying to think of ways to promote this topic within the NLP community. And we released a set of recommendations and guidelines for researchers, how to better align their research with efficiency, how to promote efficient work when reviewing papers, when deciding on papers, trying to make better judgments about when a scientific contribution is a valid scientific contribution, rather than just saying, okay, we ran a bunch of experiments and here is what we found. So we're getting quite a lot of positive feedback from the community about these topics.
My friend Kim Hazelwood, who works at Facebook, I think one of the things they're promoting is this notion of, hey, this model is great, we trained it, but in the process of training it, we consumed this much energy. Kind of like part of the disclosure somehow.
That's another great point. I mean, I think this is something we're starting to see over the past couple of years, and this is something we definitely didn't used to see 3 or 4 years ago. I mean, people adding, you have this ethics statement, you also have this energy statement of, okay, we released this huge model, this is how much it costs. Google just released, I think, earlier this year, maybe late last year, a paper titled something along the carbon cost of training large neural networks. I mean, so people are starting to care about these topics and starting to care about being honest and being open about the cost of these things. And I'm delighted to see these kind of results, and I think they're super important for us to quantify, to understand how big is the problem, because part of the challenges here is that we don't really know what's going on with these huge organizations.
And by the way, it's not just that, okay, here's GPT-3, this is the model, this is how much it costs us to train it. Now that the researchers are using tools like MLflow for experiment tracking, what would be ideal is tell us how much it costs to arrive at this model. Because
exactly, that's one of the
you may have gone through so many wrong directions before you got to this huge model, right?
That was really one of the motivations of the Green AI paper. We're saying, give us the price of an of a scientific result. It's not just, I mean, training your last model, how much it costs, how much all the steps along the way that you tried and didn't work. I mean, this is a super important point.
Right. So the other area that you're kind of focus on is biases in data sets, and I'd like to talk to you about that. But before we do, I don't know, to what extent, Roy, are you following this notion of detoxification of language models? You know, because part of it, remember, as you pointed out earlier, OpenAI didn't want to release the earlier versions of GPT because of possible negative applications. But and now there's this research direction around detoxification, but as best I can tell, that's nascent, and also the results are somewhat mixed, right?
Yeah, I mean, I must say I'm not a big expert on the topic, so I prefer not to comment too much. I would say, I mean, yes, this is a very growing field of NLP, and a very important one, obviously. I mean, these models are becoming a more central part of our life, basically using these applications in various domains. And we want them to, not to use foul language. We want them to be respectful, to be not to be racist, not to be sexist, not to be anything of that type. And I think this is basically a hard problem. I mean, you can try to hide this information from them during training, which is the typical approach. But then I think what might end up happening is that the models, without the models ever being exposed to this, to say racist terms, they might come across them when you're fine-tuning them or when you're conversing with them and not know that you're using it in wrong context. I mean, I think for you as a person, for you to not use foul language, you have to know the foul language, and you have to know, no, now is not the right time to use this word, or never is the right time to use a given word. So, I mean, I think this is a very hard problem, and especially when you have these huge models, and the best thing you can do is filter out some of the content. And not only that, I mean, this is hard because you have obviously so many adversarial agents who are trying their best to poke at the model and make it output such toxic language. So yes, this is a super important problem. Unfortunately, I'm not one of the experts on it.
So in closing, I can talk to you forever about these things, by the way, but we have to wrap up. So biases in data sets. So high level, what's happening there? Is it is it researchy, or are people actually starting to release tools to help people in industry?
Yeah, that's a great question. I mean, I think that originally, I mean, my interest started from a pure academic interest. I mean, maybe it's not pure academic. I mean, I was very interested in when we see, basically, when I'd like to give this following analogy. Say that you take a math exam and you got an A or an A+. Then we wouldn't say necessarily that you know math, quote unquote. We say that maybe you practiced, maybe you worked on some exams from previous years, maybe you found some shortcuts, you see how the question is framed, and you know, okay, this doesn't make sense as a solution, so I'm going to cross it out, and now I have a better shot. And maybe surprisingly, maybe not, models are pretty good at finding these shortcuts too. And so we had some earlier works where we took a data set of when we have two inputs, say a question and an answer, and now say, okay, what happens when we cross out or say an answer, a question and a passage, and you have to give some answers. So what happens if you only show it the question without any passage? So ideally, you would expect the model not to perform very well on this task because it doesn't have any information, but we found it to do quite well in these partial input cases, which basically means that the model is able to pick up on some correlations and succeed even without understanding, quote unquote, the question. So this was work that I did a few years back, and ever since people have started, we call these things annotation artifacts because they're typically a property of the data set that we're using and the annotation process that created it. And so ever since, myself and others have been trying to find ways to both reveal more of these artifacts, more of the problems that in our data sets, and trying to find ways to mitigate them. There's been a lot of progress over the last few years, but I mean, this is also a very non-trivial problem to solve.
So it's not
just about.
we're not at the point where I can pip install a tool and point it to my corpus and it'll surface problems.
You can pip install it. I'm not sure if there's an actual tool that would do that, but there is the technology to surface problems. Definitely, yeah. I mean, you can just run simple statistics and see that there's some correlation between several words. Say, if you want to identify contradicting statements, the word "not" is a very strong indicator of contradiction, but it's definitely not understanding.
So Roy, this sounds like a great project for a master student.
I have a couple of them doing that.
Who want to contribute to open source, so.
Totally. So I mean, if you can do simple statistics and get some information about how much biases are there in your data, and whether your model is on track in actually solving the task or just exploiting some of these problems. And I think if I were in industry, I think the main question is, what is your use case? Maybe you're fine with models having biases, this sort of biases, and maybe all the inputs that you're expected to receive are those that contain these biases, and maybe it's fine to exploit them then. But if you want something that's general and supports unexpected input, being robust, then you have to be aware of these topics and try to find ways to make your models more robust. And this is something that myself and others are trying to do.
Yeah, and just generally, a lot of these models, I think basically we're at the point where we just go to a model hub and kind of trust them blindly, So there's a bit of a whereas before, as you and I probably worked on NLP before deep learning, you probably were a little more hands-on and kind of could understand what was happening. But now there's a lot of, you have to trust the model somehow,
Yeah, I mean, we didn't have Hugging Face, unfortunately, back then. Totally. I mean, I think even nowadays, there's no. I mean, you can get by without looking at your data, running your model on a few examples, trying to get a sense of what it's doing, what it's not, is it not doing, trying to be a critical thinker in terms of. I mean, this is what I'm trying to do. Is the model really doing what I'm thinking it should? Especially, I mean, if you have an application that's sensitive and you need and there's a high cost of making wrong predictions, then it's definitely no way around it.
By the way, this is definitely the last question. But
I'm enjoying it. Feel free to continue.
As I mentioned, I can talk to you forever. But so everything we've talked about so far, to what extent is it tied to English? So in other words, everything we talked about, does it map over to Mandarin, to Korean, right? So.
That's a very, very good question. Unfortunately, most of my research focused almost exclusively on English because most of the data sets and the benchmarks are in English. I know many people, even within my department, are working on other languages and trying to find how generalizable these techniques are. I mean, some of the more established ones, I don't know, distillation, have been shown through many languages. But some of them are language independent.
Generally, Roy,
quantization.
Generally, Roy, the other languages also benefit from things like transformers, right?
Yeah, totally. Yeah. I mean, you have XBERT, where X is some language for many languages, using basically the same architecture. There are definitely challenges in tokenization and that sort of stuff, but I mean, transformer have been shown, as I said multiple times throughout this talk, to be a very, very robust tool.
And there's actually NLP researchers who are working on languages where there's just not that much data, right? So.
Exactly. And the question is how much, I mean, efficiency is super relevant there also, right? I mean, if you don't have enough data, then you can't pre-train forever, and you have to get by with what you have.
Yeah.
Totally.
And with that, thank you, Roy.
Thank you so much for having me. I had a lot of fun.